On. That was actually better than I expected. Awesome. You guys are kind of awake. Python 3, it's time. If you don't want to listen to this, then I'd be surprised why you're in the room. I'm Charles Yost. This talk is being given at DerbyCon. I think the date's right. So we'll move on. This is just a summary, recapping what you probably already read. Basically, we're going to talk about Python 3 and why it's time to move, or at least get started moving to Python 3. We're going to cover some of the details, some of the reasons why it's a good idea to move, what you get by moving to Python 3, pitfalls that you might encounter, and just some general tactics for how to handle a transition you might be going through or setting up a new project that you want to use Python 3 with. As I said at the top, I'm Charles Yost. I've got a varied background. You probably already read this if you wanted to as well, so we're just going to skip over it. But if you need to get in contact with me, have any questions after the talk, you can contact me via Twitter. I also have my GitHub and YouTube handle up there because I try and keep track of the videos that are recorded and put them up on YouTube. And actually, all these slides are text. And so if you ever need them for reference, you can find those on GitHub. So why now? Why is it time now to move to Python 3? What's special? Is there something that's changed, some sudden effect that's happened? No, it's been time to move for quite a while. But now is the best time. Let's go through a bit of history. How did we get here, right? Why am I even talking about moving to Python 3? It's just a new version, right? Well, we can start all the way back in December of 1989, when Python was just a glimmer in Guido's eye, and implementation started of it. 1.0 came out January 1994. And in October of 2000, 2.0 came out. This was a very important milestone, and one of the things it brought along with it was support for Unicode. Now, if you're not familiar with how computers actually look at text, it's stored as bytes on the disk, and if you want different characters for other languages, you have to come up with a way of storing that in bytes, and that's Unicode. We have the capability to encode way more characters than we will probably ever use. But Python, up until this point, didn't have the capability to access it. Finally, now we do. 3.0 came out December of 2008. Now think about that date a little bit. We're in 2016 now. So 8 years, roughly, ago, 3.0 came out. And I'm telling you right now, it's time to move. Big thing with this was strings as bytes. You might have heard of the Unicode issues because of 3.0 and the fact that now something was going wrong and anything from a Python 2 code base was having problems and something to do with strings, and we're just going to leave it alone. 2.7 is fine, right? It'll just stay there. Well, if we look at Python 3.0, it really wasn't just an update, right? It wasn't just a new version. It was an evolution of Python. It was moving forward with something that Guido had wanted to do for quite a while, shedding some of the old changes, getting rid of some of the old cruft and things that had accumulated and not turned out quite right. Things like the Unicode support. Unicode support was there and available in Python 2, but it wasn't quite as nice as it could be. So what happened? 3.0 came out, solves all our problems. Shiny new thing. We want it, right? No, not quite. With this big of an overhaul, there had to be some collateral damage. In this case, poor performance, particularly I/O. And that slowed a lot of people down from adopting it. Also, chicken and an egg, right? We've got Python 3.0, but none of our wonderful packages support Python 3.0 at this point. When it was first released, there were a couple that had decided to give it a try, the Pi 3K project, and see where we could go with it. But, you know, by and large, the things that people were using day in and day out, they just weren't there. So Python 3.0 kind of fell flat. Python 3.1, right? Quickly on the heels, June of 2009. Better, but still had issues. Still had a lot of issues. In fact, some of the issues were even dealing with the encoding, the Unicode support, that was a big pivotal part of this. And so 3.1 came out very quickly. People continued to just kind of ignore it and stay where they were. Python 3.2, okay, another minor one, February 2011, a little bit more time here. Much better. A lot of the problems with I/O performance was fixed by going to some lower level C APIs instead of using Python exclusively for the I/O. A lot of the issues with Unicode were tracked down and fixed because of advancements that had been made in how errors were handled. And all in all, it actually ended up being a pretty good choice, right? It was a good starting point. Now we finally have a version that we can build on. It brought along WSGI. If you don't know what that is, it's for web applications. If you've ever heard of Django or Flask, WSGI was pivotal for making sure that Python 3 was going to be accessible for web application development. And 3.2 is when it came out. Many packages, not all of them, I wouldn't even say a majority, but many packages chose 3.2 for the version to begin supporting the Python 3 line, if you will, 3.x release line for their kind of splitting point, right? 3.0, 3.1, there just were too many issues. They didn't want to go back and support those. So 3.2 was a very common choice, and you'll still see that in a lot of packages that they require at least 3.2 or greater for Python 3 support. So we've got another version, Python 3.3 in September 2012. Let's talk about this a little bit. It's the first release without a corresponding 2.x release on the Python 2 line. So let's rewind a little bit. I've been talking all about Python 3, but while we've been going through Python 3.0 and 3.1 and 3.2, we had 2.4, 5, 6, 7 right alongside. And so 3.3 didn't have a Python 2.8. Still doesn't have a Python 2.8. In fact, there won't be ever a Python 2.8. Many packages finally started to jump on board at this point as well. There were some advancements and improvements that came along with 3.3, something called virtual env that we'll talk about a bit later that might have an odd name for what it actually does. And there was more and more support being garnered, not to mention that a line had been drawn in the sand. The 2 branch was dead. This is in September 2012 when this happened. Once again, we're in 2016, 4 years. So let's continue to go forward and see where we get. So today, Python.org maintains a specific wiki page titled, "Should I use Python 2 or Python 3 for my development activity?" Seems like a good reference, you know, we should be looking to them to guidance and figure out what we want to do. Direct quote, short version, Python 2x is legacy. Python 3.x is the present and future of the language. They've sent many signals, this is just one of them, that Python 2 is dead. It's going to be end of life soon. It's no longer getting the feature enhancements and the push forward that Python 3 is. It's dead, and we need to find a way to move forward off of it. In fact, support for Python 2.7 ends in a little over 3 years. And just for fun, that's the actual countdown. So that's the amount of time we've got left. After that, support goes away. Now, I can understand there are going to be projects and tools and scripts that you have that you really don't want to move away from. It's what works. A lot of times Python 2.7 is what's installed on the system when you first get it. That's changing slowly. But it's really not about all of that stuff. It's more about the business critical applications, the things that will no longer have any kind of security patches for after 3 years. I'm a little over, obviously, but this is what we're staring down the barrel of. We've got a large amount of advance notice. We've known for 10 years that Python 2.7 was going to be the last iteration of the Python 2 branch and that it was going to go away. And I think 3 years is enough time to make a change. I think that we can move forward and do something better and not end up with another PHP. So, how does it look? We have the idea that we want to move forward, but nothing's created in a vacuum, especially with Python, right? One of the amazing things about Python is the cheese shop and all the things that you can get there, all the wonder that you can find. Well, a couple of enterprising individuals have started maintaining lists of how close we are to being ready. 94% of the top 360 packages have been ported to Python 3. There are some holdouts. Most of those have alternatives now. But most likely, the packages that you're using, either day-to-day or periodically in scripts, any data processing you need to do, they've already been ported. NumPy, SciPy, it's already there. And there are excellent ways to get a hold of those. But we won't just stick with one list. Let's take a look at another one, not to mention it's got a fun name. Python 3 Wall of Superpowers. 93% of the top 200 packages have been ported. This is really important, right? This is why now is the time. You've got the support of the community. The packages have moved forward, either been ported or replaced with better alternatives. And there's a lot of benefits to be gotten. You know, the Python 3 isn't just a new number. It's not just incrementing by 1. There's a lot of changes that went into this to differentiate it from Python 2. So let's look at some of those. They might even be able to be turned into, benefits that you can pitch to management if you do need to move a project forward that you have to get clearance on. And security is a very underlying one of those, but there are also benefits to be had just from working in the language. Also, this is a list of very good reasons why any personal projects or personal scripts that you've got are at a really good point to start using in Python 3. Either porting them, rewriting them, or new ones, just start out with Python 3, and that way you won't have to come up with a solution in 3 years, 6 months, and change. First off, we talked about this a little bit already, better Unicode support. This is how computers store characters. When I'm typing on my keyboard, the computer doesn't understand that that's letter A or B, right? It's storing it as ones and zeros, blazing past on the disk. Well, the world is becoming more and more Unicode-based. We've got internationalization from businesses and all kinds of data being open-sourced and exchanged from various research institutes and places of learning. And it's only going to get more so. We're only going to be handling more Unicode rather than less. We're not going to go back to the dark ages and use, UTF-8 or ASCII, heaven forfend. You're going to need to support it, so why not just pick up the benefit that Python 3 has it built in? It's not just tacked on the side either. This is down in the core of the language. And as far as security benefits, you can have less dangerous string handling. If you know anything about sanitizing inputs, this is a perfect example of setting yourself up for success with that. Also, because most likely you're not going to write anything that's going to exist in a vacuum, reading files, any files that you're ingesting, or streams of data even, it's not really restricted to files. Those are a lot more straightforward and easier to understand. Am I dealing with text that I know the encoding for? Am I dealing with bytes? Maybe it's a packet capture, right? And you want the bytes from it. Maybe it's a text file that, somebody left on their desktop containing their passwords, and you just want to read that. Either way, reading files is a lot more straightforward, and it's something that's a lot more intuitive. Before, you would just kind of get a weird stream of bytes. I opened this as text, and it's UTF-8, but actually it's got Unicode. What is going on? Why does my screen look all glitched? Now we don't have to worry about that. Integers, right? Playing with numbers. The next thing up the scale from dealing with text and ingesting that and messing around is dealing with numbers. So right off the top, there's no longer two separate number types. If you've used Python 2 a lot and you've gotten used to ints and longs, long is long gone. Now we've just got ints. And it's much more of a Pythonic situation. You don't have to worry about the size, right? If it was an int, it was a small int, and so if you overflowed, all kinds of bad stuff could happen, which really was odd for Python. Now we don't have to worry about that. It's all just rolled into one type. Also, division works like it did when you learned it in second grade. Does anybody know what I'm talking about? Python 2 just kind of rounds off the end for fun. I can't tell you how many times that's introduced a bug that I have no idea what's going on, and it's just that simple. Division was really weird. I don't understand the provenance of why it worked like that. Now it works the way that you would expect it to. You've got a remainder, you just go forward. I mean, they did keep the truncating division. They put it under a different operator, a double slash instead of a single, but that's, in my mind, a better way to go about it. Question? Yes. And you don't have to do 1.0 divided by 3.0, right? Yes. If you want that previous behavior, you can maintain it. There are times where it's useful, and that, like I said, is a double slash. Instead of a single slash for division, double slash and it'll round it off. But, I mean, even that makes a lot of sense for Python as a language. Having that separate operator that can be picked out really easily. Oh, this is going to behave differently than I expect. So I really think that was an awesome choice, and it was something that they had to break backwards compatibility for, right? This is why it's so hard to take Python 2 code and port it to Python 3, is because little things like that had been built up, and they weren't going to just change the operator silently. It would completely mess with anything anybody had ever written for scientific or mathematical purposes. So we'll continue forward. Comparison simplification. Fancy words. All this really means is that instead of getting odd behavior when you say compared a string to a number, now it just errors out. You get an error, and you can handle that however you want. But this is another example of a thing that they had to kind of let go of and create a breaking change, a non-backwards compatible version in order to fix. Never really made sense. I mean, we've got JavaScript if we want to go comparing numbers to strings and truthy falsy stuff. Why do we have to deal with that in Python? Well, Python 3, we don't. And it's very specific and very clear about where the issue is when you have an issue. You don't have to go chasing it down and figure out what comparison messed up. This does have a side effect, that a sortable list requires all the same type of objects to be in it if you want it sorted, which isn't that hard to cater to. I honestly can't think of a time that I've had a list with multiple types in it that I wanted sorted, so that's interesting, but it is something to consider. And this is just another example, like I said, of breaking backwards compatibility. They had to shed those changes and move forward, and it's the reason why Python 3 has so many great benefits and why it's so much work to port. Exception handling. I was just talking about errors from comparisons. Exception handling has gotten a lot better, and you can read the text of what's there, but the long and short of it is that it's a lot clearer and easier to read. Basically now when you've got an exception, it's got a clear inheritance as far as where it came from. It's got a clear way of handling it. You don't have that weird comma grammar that you had in Python 2, which always made me think that somehow it was dealing with a tuple, and it wasn't. It's just a lot clearer and more straightforward, not to mention that It has the added benefit, one of the things they were able to implement, once again a breaking change, is the fact that your variable that stores, or your tag that points to your exception, is actually scoped to the except clause, to the catch in there. And that means that you're not going to leak that out and have issues if you have nested exceptions or anything like that. Virtual env is built in. Does anybody have experience with virtual env? How much did you hate it in Python 2? That's my sentiments. I wanted to use it. It was awesome. We'll actually go into how to use it and what its benefits are a little bit later. But if you tried it before and were frustrated by it, in Python 3, give it another chance. They've done things right. And I'll give you a quick rundown if you've never used it before on how to actually go about using it. But it's built in. You don't have to install it. You don't have to do some kind of weird chaining for it. It's just there, fully supported, and works better than ever. There are tons more features, obviously. Right at this moment, actually a couple of days ago, I believe, the first beta for 3.6 came out. And so there are tons of changes, async, await. I'm sure that if you guys follow it at all, you've seen all of the amazing features that you're missing out on by not using Python 3, but we're not going to grind over them right now. The point is that there is a ton of benefit to going to it, both programming-wise, security-wise, just maintaining old code, right? It works. Why would I change it? Well, it works right now, but do you understand how it works? And are you willing to do security patches yourself for it? That looks like something that's a little bit bigger job than I want. So let's go on to the next part. What to watch out for. Say you are going to start porting these pieces of code that you might have, or this project. What are some of the top things that are really kind of going to bite you if you go down that road? First off, and I'm sure you've all seen this if you've done any searching for it at all, the print statement is a function now. Have to use the parentheses. Python being Python, it's really lax about you putting space in between the actual function name and the parentheses, but you have to use the parentheses. I personally really appreciate this change because I always ended up introducing odd spaces into my print statements. I don't know if you guys experienced that at all, but in Python 2, I'd do a print, I'd try and put together a list of variables, a couple of strings interspersed with it, and I'd get something out that I didn't recognize. Now we have two types of string formatting. We have a print statement that's a function, so you're just passing it one thing. Things are a lot better than they were. But it is something to watch out for, and it's probably one of the first places you're going to start if you start porting your code, is just to switch any print statements. Also, side note that I didn't mention on this, the print statement now has the capability to print to essentially any buffer. And so if you want to print to a file, you can do that. It's kind of neat. Maybe we'll take a look at that later if I have time. Next thing on the list, dictionaries. That's disconcerting. It was coordinated. Dictionaries. Dictionary keys, items, values are views. This is another gotcha, and one of the reasons why it's so high up on the list is because it's really easy to get caught out on this one. Views, what does that mean? Well, instead of a list of items, say you wanted a list of keys, right? You're not going to get a list of keys. You're going to get a view of the keys. And that view is not going to be able to be changed because you're just looking at it, right? You don't actually have the list of them. So if you sort that view, it's just going to sort the view, not the actual dictionary. Map and filter return iterators. We haven't talked about iterators at all yet. Those are another awesome thing about Python 3, how it works with those. But it's something to keep in mind. The iterators are a lot lighter weight on memory, but unfortunately they have the drawback that you won't get items directly from them. The easiest kind of hack for this is to just wrap it in a list. So list, open parens, map, whatever you're doing, map, and then close both sets of parens will give you a list of the values right off the bat. As you move forward in Python 3, you'll probably find yourself dealing with map and filter and generators a lot more, and that means that your program will be more efficient, consume less memory, and you won't have to do that kind of hack. But if you're just porting code directly, a lot of times that's what gets suggested, and it is one way to handle it. Also, range now behaves like xrange, and xrange is gone. It's just another thing to keep in mind as you go through and work through the code. You'll find this, it's pretty much a straight swap. There's a couple of extras now that range does, but it's a pretty easy thing to get caught out by. Why am I having trouble running this? Oh, it's crashing because xrange is gone. The long type is gone, just use int. I mentioned that before, and it really is that simple. Anywhere that you're dealing with the long type, just use int, and you won't have any issues. Text versus data. This is another way to talk about the whole Unicode thing, right? We've got text, we've got data. Another way to say it is we've got strings, we've got bytes, and we've got byte arrays. And really, this is a good thing. It's very painful to deal with a Python 2 code base that you're trying to get to 3, and stuff's just not lining up because you thought it was a string, but now it's got an encoding error. In the end, this can be a really good exercise to just kind of clean out some of the issues that you might not have noticed in your system. You're going to have to deal with it in 2 places, only 2 places. The first one is if you take in any input, like a file or somebody typing at the keyboard. Once you figure out what encoding you want that in and go forward from there, the second place that you'll hit it is when you're saving data out, right? So if you're saving something out to a database or to a flat file, CSV, that's another place where you have to count for it. But that's pretty much at the edges, and that's where it should be, right? You want to be careful about what's being encoded how at the edges of your program. Internally, it's actually a lot nicer and a lot easier, so you don't have to worry about weird situations where you have, you know, strange byte arrays or strings hanging out there. And of course, there's many, many more of those too, right? There's a lot of changes, there's a lot of differences, and so it's something that you're going to have to address. When you're doing this, there's good news. There's a tool called 223. And basically, if you run it over a code base, it will tell you all the places that you need to change something. And a lot of the things that'll come up will be like those print statements, or putting in encode and decode for strings. It's really straightforward to run. Its output is very easy to parse. And if you want to make this a long-term campaign, if you have a big project that needs changed, 2 to 3 is definitely the way to go. Very easy to automate. So let's take it slow, right? Maybe we don't need to do this thing all at once. Maybe we don't need to just port whatever crazy project. Maybe we want to take some baby steps, go a little bit slower. Well, the good news is that there are ways to go from Python 2 to Python 3 without a direct cut, right? It's been years at this point. People have built up a lot of tools and a lot of ways of coping with this. The first one is just the Python future module. And you can find documentation about that on Python's website, and it provides a bridge for some of these things. So like the print statement. You can say, okay, well, it's just a goal for this week. I'm going to eliminate all print statements. I'm going to make them print functions. Easiest way to do that, import the future module, import the print statement part of it, and basically you can then swap those out in your code. It'll still run on Python 2 just fine, but syntactically it will be ready for Python 3 in that way. There's even more help. Python-future.org actually gives you a future and past module and a couple others as well. And this allows you to continue down that road much more thoroughly than just the future module. It allows you to swap out all the things you can think of going from Python 2 to Python 3. Therefore, preparing your code base, preparing you for when you might actually run it under Python 3. Doesn't have to happen overnight. You can work at it little by little, get it right, and then make the transition. Another one of these is 6, which is Python 3 or 2 to 3 compatibility, hacks and fixes and patches, all kinds of little things in there. These are all excellent ways to move forward with this, and it might seem like a monumental task, especially if you have a large code base, you run something against it, like 2 to 3, and find out that you've got thousands of things to change. The good news is that you can do those changes little by little and just make an impact over time. You've got 3 years, right? It's theory. Another thing about 2 to 3, as a side note, it can fix some stuff itself. That's a decision that you'll have to make whether you trust it or not, but it is a possibility and it can make things a little bit easier. Okay, virtual env, I mentioned this. And I know this is all fairly dry material, but this is actually pretty exciting for me. I don't know if it'll be exciting for you guys. Virtual env, right? Virtual environment. Well, first thing you think of is virtualization, VirtualBox, or VMware. Wait a minute, we're talking Python here. You don't need a whole machine, right? Python, the way it works, essentially it's got python.exe and a whole bunch of library things, packages and modules. So what do you need to create virtual environments for it? Well, essentially you just need a copy of those things. And make sure that when you run Python, it's pointed at that copy instead of your whole environment. Well, come to think of it, if you're trying to go from 2 to 3, and you need a Python 2 environment and a Python 3 environment side by side, this might not be a bad way to do it, especially now that we've got the better version that's in Python 3. Comes built in and just works a lot smoother. Included as of 3.3, I mentioned that. The VENV module provides support for creating lightweight virtual environments with their own site directories, which is just a fancy way of saying it copies all the stuff you actually need so that you don't overwrite the ones that are on your computer. In order to create one of these, it's pretty straightforward. Most of these commands, if you have your environment set up correctly, you don't need to call python-m, but there are instances, and I've noticed a lot of this in Windows, where I just don't want to mess with the path environment variable that much, where it's easier to just call it like this. And you can do this with any Python module. So python-m, virtual env, and then a directory name. So, I don't know, Candy Shop 3, and that'll be your port of Candy Shop to 3. Go ahead. There's no distinct advantage other than you can be a little bit lazier. It resolves it slightly different. Obviously, if you use the path environment variable method instead of running the module like this, then you're dictating its resolution, right? You're saying, look for the virtual env script at this location. And if you know where that's at and you know what you're doing with it, there's no problem with that. There's no advantage to doing it this way for that. But this is one way that Python can just resolve it itself, so you don't have to worry about adding that in. So once we came up with a directory name and we've created the virtual environment, we need to enter it, right? In this case, I just kept directory_name as the name, but for Windows, it's a little bit different than it is for the other OSs. On Windows, you want to do directory name, scripts, activate. On everything else, directory name, bin, activate. Tiny difference, something you probably won't notice, but something to keep in mind if you can't figure out why it's not working on Windows versus others. That does remind me of a tangent that I'll go on real quick. Python 3 in Windows, particularly 3.5 and coming 3.6, has gotten a lot better than you remember it as well. If you've ever struggled with it and you don't understand why you're fighting with it and having so many issues, it's been smoothed out quite a bit. So that's another thing that you might give a second try. 3.5 and 3.6, the installer works a lot better. You don't end up with some of the oddities that were introduced by it. It's just gotten a lot better, a lot easier. And I mean, with all the other trouble that you have going on, easier is better. So after we've entered the virtual environment, we're probably going to have to keep track of dependencies, right? And so you might be aware of pip and requirements.txt. Pip is just the package installer, apt or yum or pack or any of those. Pip is Python's version of it. And requirements.txt is where you can store that list, right? The reason that I bring these up in conjunction with virtual env is the fact that pip and requirements.txt can then allow you to restand up an environment, copies of the environment, the exact same way every time. And so as you go through this porting, you don't have to maintain the same one, copy it between systems. You can actually stand new ones of these up. In fact, in order to save your list, if you've got a pre-existing environment, maybe you're starting from something in production where it's already deployed. If you run the command pip freeze, which can be done as python tac-m pip freeze, or just straightforward like this, and pipe that out to append that, rewrite it, redirect it to requirements.txt, you'll end up with a list and all the version numbers associated with it in the requirements.txt file. And that means the next time that you need to stand up another environment, you can pass in via the tac-r or -r argument that requirements.txt, and it'll install everything for you. So this is awesome if you're trying to replicate something from production back to a development box, or if you just need multiple copies on your development box, this is how you can keep track of it and re-stand up those environments very quickly. Also, when you get done, you're going to deactivate. Now, if you've got a bunch of shells, you can just close the shell, it'll automatically deactivate. Again, this is really just a set of folders, right? The libraries and the executable copied into that set of folders. That's all. And so going in and out of it is actually just rewriting your environment variables to say, hey, when you type python.exe, point at this one instead of the one on your system. And this is how you can maintain multiple versions of Python, right? You can actually set up a virtual environment that says, okay, well, this python.exe is 2.7.10, and this one's 3. And keep that separate, switch between them. Don't have to worry about odd dependencies on your system because the dependencies will be installed. Pip will put them into that virtual environment it is in to keep it isolated. So it's just a really good way of dealing with trying to port an application like this or any other bits of code that you've got. I actually do this a lot even for little scripts that I have that don't really have that many dependencies, but I just want a stable environment so that if I go and update Python on my machine, it doesn't suddenly break the environment that script was used to running in. It's the last thing you need on a Friday, right? One final note about all this porting stuff, right? If you go through with this, you're dealing with a lot of tools. You're going to be dealing with a lot of changes. It's adding another couple of tools to the stack, but Pylint and whatever test framework you like. If you are a developer or know a developer, they've probably got a favorite test framework for Python. Pylint is just a linter. If you've dealt with those at all before, that can be very useful as well, especially dealing with some of the syntax differences, right? It's quicker to see that from a Pylint report than it is necessarily to loop through and just change everything with 2 to 3 constantly. So, wrapping up a bit early, unfortunately, but that just means I have more time for questions. I wish everybody good luck with this, because this is a long, arduous fight, but we're going to keep going forward because we only got 3 years left, and that'll kind of suck if we don't do it right. Anybody have any questions? Okay. Thanks for your time.